Assalamualaikum warahmatullahi wabarakatuh. And very good day to all of you. This is a video on software reuse. So these are some of the content that we are going to cover in this video. We are going to look at, there are actually for reuse, there are many approaches, but we are not covering all. Basically for this, in this video, we are covering only two main approaches in reuse, which is application framework and software product lines. Okay, I think you have come across with the term reuse for quite some time already. So basically, in software engineering, not all of the system are being developed from scratch. Okay, some of it are being developed out of reusing some of existing component. And for software engineering, I have mentioned before, most of it more focused on developing software, but after quite some time, because there are available software already being developed, so some of it can be reused in building another new software. All right, in reusing components or parts in the software, I could say there are four types of reuse. There are system reuse, application reuse, component reuse, and object and function reuse. As you can see here, you can see in terms of the different levels, you can see this is a slightly larger level compared to the lower one, which is at object and function level, where it is more at the programming level, where it involves reusing some of the object and functions that are being written by the programmer. Okay, there are also reuse in terms of the system, where we are reusing, meaning that we don't build it a new software, but we are reusing existing system, right? Whereby in application reuse, it can be maybe reused either by incorporating it without change, meaning that you are using some of the existing application without changing it, or by developing application families, meaning that you are combining it with other applications in order to build a new system. Whereby in a component reuse, we are actually reusing parts or subsystem of another system in order to reuse it in building another new system. Right, as you can see that we are recycling or reusing existing components. Of course, it will accelerate development because you don't have to develop everything from scratch or from zero, right? And then you can effectively use our specialists, meaning that because the components or the application that you are using already capture some of the running processes that have been used before, so all the detailed information on the processes, on the procedures captured by the application already been checked. Okay, so it has been tested by specialists. And also because we are recycling or reusing existing system, so of course we know that this system is depending on another running system. Okay, so so that would be also benefits of software reuse. And of course, you are going to lower the development cost because some parts of the system is already available, and then you can reduce process risk because we don't develop it from scratch, so some parts of it are already running. And another benefit is related to standards compliance, meaning that some of this component that we recycle are sometimes already being developed following certain standards. Okay, for example, in this case, sometimes you can recycle existing user interface standards, for example, the menus and so on. So some of it are being developed following certain standards. So rather than developing it from scratch, you can straight away recycling it or reusing it. So I could say that not everything reusing is simply like plug and play. So it is also come with its own challenges. It's actually among the problem with reusing is creating and maintaining a library of component reuse, meaning that all the things that can be reused need to maintain in one place, so that it's easier for us to go and look around for existing components or methods or system. It's not an easy task. Okay, you basically have to think about, okay, which component can be reused. So in that case you are putting it in a database or a library. Okay, these come together. And also because we are reusing existing system, the 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 cost can come not on the development side, but on the maintenance side. Okay, you need to maintain the component that you are you you are reusing it. Okay, so the cost of maintaining the system, meaning from time to time, you need to ensure that some of the codes, do you need to perform any additional testing because you have added it, you have integrating it with another system. So therefore, you also need to do some sort of testing that will increase the maintenance cost. And also, um, because some of this software that you reuse are maybe developed for quite some time, due to that reason maybe the tools that was used before to support it is no longer exist. So that's another challenges here. All right. Um, and there's another problem which is called non-invented here syndrome. Like some of these software engineers, they are more creative. They don't like to recycle or reuse existing system. They are more into developing their own. So uh, um, maybe they don't trust existing system because they could not see the detail of the implementation. So due to that reason, they do not trust it. All right. Let's have a look. I could say that after quite some time, due to um, different methods used in reusing system, there are many approaches. So some of it maybe you have come across with it before. For example, legacy system wrapping, okay, component-based software engineering. These are all methods that support reuse. Okay, program libraries, for example, when you are doing your programming, you are calling certain API, so that are something available already and you simply reusing it. And also there are design pattern, architectural pattern. So basically these are more on existing pattern that have been developed after quite some time, where programmer have been developed program and then they identify there are some specific pattern that they often come across with, so they capture it, um, and and those who are doing programming will recycle or reusing some of the patterns so that their program in more elegantly designed. Okay, so there are many, but the one that we will come across with in this video is related to application framework, software product lines, application system integration, ERP, and also configurable application system. Okay, let's have a look. I have come across with some of these. The one that we are going to concentrate on is actually application framework. Okay, application framework is actually running system, but basically it will provide only core function. Okay, so using application framework, you can build another system on it. They are only application framework will only provide you with core classes. Okay, basically it's a collection of program containing abstract and concrete classes that are going to be adapted and extended to create another system. So it's basically provide you with core function and then you build up another you build your system on it. Okay. And also application system integration approach, whereby two or more application systems are integrated to provide extended functionality. The rest I leave it to you to read. Okay. And then we are also going to look in a very surface level related to configurable application system. So these are domain specific system which are designed so that they can be configured to the needs of specific system customer. So that this is a more of a system ready system which is very specific to domain, for example related to e-commerce or bank, where you customize it. Okay. And also ERP. So ERP, when you come across with the term ERP, enterprise resource planning. All right, so it is actually a very large system where you can configure it. There are many modules you can, when it is actually a ready system, where you can customize it. Maybe there are some modules that you don't want, so you don't buy it. So but basically it's for a large system where it encapsulates generic business functionality. So it has processes in it, but it's more general, it's not customized to your business. Okay. And sometimes it can be it provides a general function, but some of it some of the processes can be customizable for your organization needs. There are also program generators, program libraries, service-oriented system. Okay, these are all available approaches covering different perspective. All right, and the one that we are going to focus on is software product line. So basically, when you come across with the term software product line, it is actually an application type in generalized, which is generalized around a common architecture so that it can be adapted for different customer. I think the easiest example for software product line is handphone, your mobile phone. So from time to time there are new models which have extended functions, but the core functions are actually there. So it is being customized for different in a different model. It has, for example, better camera compared to a slightly cheaper version. Okay, and then from time to time there are more extended functions that have been developed. Okay, so that is among the easiest example for software product line. Other than that is related to your television. So you can see that the technology of television has been improved using different technology, but the core functions related to televisions are still there. Right. Okay, let's have a look at application framework. So basically this is a framework. Actually, framework in software have so many meaning, but the one that we are going to look at in this topic is related to an integrated set of software artifacts such as classes, objects, and components that collaborate to provide a reusable architecture for a family of related application. Okay, so basically, application framework here is referring to a set of running program which provide you core functionality. Okay, so in here it says framework are a subsystem design made up a collection of abstract and concrete classes and interfaces between them. And this subsystem is implemented by adding components to fill in the parts of design and by instantiating the abstract class. So the new application that are being built on top of this application framework will be extending the abstract classes. Okay. So among the common well-known example of application framework is web application framework, where nowadays for programmer, when they develop web application, they don't develop it from scratch. They actually run it on top of a web application framework that provide core functionalities. Okay, whereby they will build up and it runs on many programming languages. and most of the web application framework is running on a model which is called model view controller, meaning that some parts of the controlling are actually supported by the web application. Okay, so for example here, system infrastructure framework for GUI design. So meaning that when you are developing your web application on a web application framework, so it already provide for you a framework for your GUI design, and it allows for multiple presentation of object and separation interaction with this presentation. So these are some of the core functions that it is supporting, supported by the web application framework. Right. So, so when you are using framework, you are basically going to extend a function. So you are going to add add additional methods, for example, to tailor-made it for your application, right? And then you are going to also you can also add concrete classes that inherit operation from the abstract classes, meaning that whatever that you are running, you have to refer to what are being provided by the framework, and then you extend it from there. Okay, so the abstract classes are provided by the framework, but in order to implement it, you will going to add additional concrete classes that is utilizing the abstract classes. So what I could say here in a simpler term is framework basically provide you with the core function, and then you build up another application on top of it by extending the ready function or the provided function in it. Okay, right. Looking at the second type of reuse approach, which is software product line. I've mentioned to you product line is a product line, or sometimes called application families. So it is a collection of application that have many versions, application with generic functionality, so that can be adapted and configured for use in specific content. So basically what it has is that it has the core function, and then to create another application family, you're going to expand it. Okay, um, it looks slightly the same like application framework. Okay, and later we'll take a look how far it is different from one another. So this software product line is a set of application with a common architecture. They have common architecture, and then they have shared component, and with application specialized for different requirements. So for different application family which have different features, it will have a specialized application. So so with this software product line, it has several way of it can be adapted. Maybe you can adapt the component or system configuration. Maybe you can add new component. Maybe you can select a library from existing component, or you can modify it. So basically for software product line, you have the core function, core component, and then you have a component that you can configure, and then component which are specialized for specific product. Okay, looking at the base component here, the inner part of the diagram that you have looked just now, it provides you with infrastructure support. Okay, so it provides you with the core function that is providing you with with the infrastructure support. These are not usually modified. You cannot modify it when you are developing a new instance of a product line where you create a new product. So you don't normally modify it, you're simply using it. And then for the second component, which is configurable component, that may be modified and configured to specialize them for a new application. Right? Sometimes it is possible to reconfigure this component without changing their code by using built-in component configuration language. And for specialize the outer layer, specialized domain-specific components may be replaced whenever you are creating a new instance of product line. Okay, the difference between application product line and application framework and product line is that application framework most of it rely on object-oriented features such as polymorphism because it's using abstract class, whereby for product line, it not need to be using object-oriented technology. Sometimes it can use other platform, for example, embedded software for mobile phone. Right, with application framework, it focus more on the technical functionality rather than domain specific. Okay, because I could say application framework is a more um, tailor-made to object-oriented and it's very specific for certain function, whereby for product line it is an embedded domain. It is embedded embed domain and a platform information. Product line often control application for equipment, okay, rather than application framework is more on the software side, but product line also covers on the hardware side. And product line are made up of a family of application. Like I mentioned to you just now, for mobile phone, it has many version, right? So some of this product line component is covering on the hardware part and normally owned by some organization. Right, with product line also come with its architecture because it need to design so that it can be expanded for different version or different instances of product. So architecture must be structured in such a way to separate different subsystems and to allow them to be modified. So as you can see just now in the diagram that I've shown to you, there are base, there are configurable component, and then there are specialist functions. So this architecture basically is a more general architecture of a system that can be expanded from time to time. So some parts are more, you need to design it so that some parts can be changed and can be modified. Okay. The architecture should also separate entities and their descriptions and the higher level in the system access entities to description rather than directly. So these are more like to say that the architecture should be made very flexible to accommodate any changes in the future. Okay, application system use. So it says here an application system product is a software system. So application means software that can be adapted for different customers without changing the source code of the system. So maybe most of the time, if you design a system to be reused, it has generic function, okay, so that it can be adapted in different environment. And application system products are adapted by using built-in configuration mechanism that allow functionalities of the system to be tailored. Okay. Application system reuse, you don't actually change the codes. You change it, you customize it based on a built-in configuration mechanism. Okay, for example, in hospital patient record system, a separate inputs form, outputs reports might be defined for different types of patient. Okay, so you have a different interface that allows you to change it. Right, a good thing about application system use that it's ready. Okay, so in terms of the you want to deploy it, it's ready, so it's have a rapid deployment. It is possible to see what functionality is provided by the application. So because it's ready, you can customize it, so you know what are the functionality. Business can focus more on the core activities because rather than trying to develop it from zero, so you can focus on the core activity that are being supported by the system. And as operating platform evolve, technology updates can be simplified as these are the responsibilities of the commercials off the shelf product, rather uh, responsible. So whenever the technology change, the changes fall on top of the vendor rather than on the customer, right? A problem with system reuse is that because the system is already ready, so the requirement of the user need to be adapted based on what are being offered by the system. Okay, so I could say for this example, you can call this application system reuse is as commercial off the shelf, meaning that the system is ready. It can be customizable, but not that much. And due to that reason, let's say if you want to, you have your own system requirement, but once you found a suitable commercial off the shelf, some of the requirement that you have decided earlier might be changed because you need to adapt it to what are being offered in this system. Uh, it says here, choosing the right commercial off-the-shelf system for enterprise can be a difficult process, especially because commercial off-the-shelf products are not well documented. Okay, some of it are not well documented, and the COTS product vendor control system supports an evolution, meaning that because you buy a ready software, you don't develop it from scratch. You depend on the vendor of the software. So whenever there are updates on the system, when the system change from one version to another version, you need to follow it because it those processes fall on the vendor. Another approach in reuse is configurable application system, right? So these are a kind of system which are also designed so that it is generic application system that may be designed to support a particular business type, business activity, or sometimes a complete business enterprise. For example, an application system may be produced for dentists that handle appointments, dental records, patient, and so on. So these are very domain specific, meaning that it is tailor-made for certain industry. Um, for example, such a system to support business function, for example, document management, to provide functionality is likely to be required by a range of potential users. For example, let's say you are designing a system for document management. It can be used across different industry, in schools, in hospital, in small offices. Okay, so you can configure it a bit so that it can support different industry. Okay, so you can see here some of the difference between configurable application system and also application system integration. For configurable application system, a single product that provides functionality required by a customer, whereby for application system integration, so this is basically an integration of several applications. There are several heterogeneous system products are integrated to provide customizable functionality. So configurable application system is more referring to one single product, whereby for application system integration, there are involving several products which can be integrated to have a customizable functionality. For configurable application system, it provide a generic solution and standardized processes. Okay, very generic process and very standardized processes. For example, document management, human resource processes is very standardized process, whereby for application system integration, it is more flexible solution that may be developed for customer processes. So the processes are customizable according to the needs of the customer. And for configuration application system, the development is focused on the system configuration, whereby here is more on the system integration. And for configurable application system vendor is responsible for maintenance, whereby for application system integration, the responsible for maintenance fall on the system owner. And for configurable application system, the system vendor provides the platform for the system. And for this one, for application system integration, the system owner provides the platform. So the different parts are, it looks overall like the same supporting reuse, but there are some difference between them. And looking at ERP, it's another approach for reuse. So enterprise resource planning, it is actually also a generic system, but it supports common business processes, for example, for ordering, for invoicing, for manufacturing. So those are common business functions. So basically, this ERP is integrating some of these component so that it supports a company needs in managing their operation. So it's basically used by a large system, and it is the generic core is adapted by including modules and incorporating knowledge of business processes and rules. So basically for this ERP is a large system. You can combine it maybe from time to time. These functions can be changed according to the needs of the organization. So for example, in this example, in the diagram shown, for this ERP for an organization, they need purchasing processes, supply chain. So this is handling who are the supplier of the product that they are using, logistic, and also customer relationship management. So basically, there are different running components following certain business rules that are being set for that organization, and it is accessing the system database. So for a different organization, maybe they have different combination of component. Maybe some of it does not require logistics, so you can remove this part. So basically, all these are providing common and generic function. So for ERP architecture, so a number of modules need to be defined that support the business functionalities. A set of business processes specifically need on the organization can be identified so that it can be customized a bit. And a common database that maintain information about the related business functions are included in the architecture. Right, and also there is also business rules that applies on the data is also specified in the architecture. So this ERP can be configurable. So you can select any required functionality in the system. For example, in the logistic just now, there are a complete module, but maybe you don't need all the functions related to the logistic. You can customize the company, the vendor that is providing for you can customize it. So you need to establish data model. What are the data needed for your organization? You need to establish it so that maybe this vendor is supporting many other organizations that deal with different data. So you need to identify what are the data needed by your organization. So you need to define your business rules. What is the expected interactions that you need with the external system. Right, you need to design inputs, outputs that is related to your system, because this is a ready system. It can be customizable, and also you need to design your business processes which is related to your organization, and then you need to set some parameters or some data that is related to your system. Right. Another form of reuse that you have come across just now is integrated application system. So these are another approach for reuse, whereby integrated application system are application that include two or more system products, or might also include the legacy system, for example, banks, okay, that have a slightly older system. You may use this approach where there is no single application that meets all your needs, meaning that you shop around looking for ready or application, you cannot find one, so maybe you need to integrate one or two applications so that it meets your system needs. When you are doing integrated application systems, there are some design choices that you can do. For example, these are some of the questions that you can think of. Okay, which individual application system offer the most appropriate functionality? Maybe you find several already, but some are having missing function. So maybe you need to find the most, the system with the most functionality. How will the data be exchanged? Right. So because these are ready system, you want to see different products normally use a unique data structure and format. You have to write your system adapter so that you can convert your data so that it meets the needs of your system. What features of the product will actually be used? Okay, maybe sometimes when you look for an application which is ready, some functions are not meant for you for your organization. So you need to identify that. example, this is an integrated system, an example of integrated application system. For example, this is a procurement system. This is a system that help an organization to buy certain specific products for the organization. This is normally used by a government or large system to handle any any buying of products from the supplier. Okay, sometimes for example, if you find almost system that meet your requirement, so sometimes you need to change it a bit so that you can adapt it with your existing system. Okay, so maybe you need to write an additional program so that it can adapt the system, maybe in terms of the handling data to meet the format that is required. So these are some of the problems which is faced when you are doing application system integration. So you don't have control over the functionality because you don't develop it, right? So you actually integrate it. So there are some, you cannot handle the performance or the functionality. You cannot change it. So there are also issues with interoperability. You cannot control over the system evolution. Maybe the application that you integrate have a new version, and the one that you currently exist using are not supporting the new version, right? And then support from system vendor. Sometimes the vendor may not offer support after you've been using it for quite some time. Okay, maybe after 5 years, if you need to change it, the vendor change to a new version, maybe you don't have support from them. So what we have covered so far is that there are many ways to reuse software, right? From lower level to higher level, from classes and methods to complete system. The good thing about reuse is that it's lowering the cost because the system, some parts of it can be recycled or reused, faster system development and lower risk. And also system dependability is increased because you are using existing software, and this software or components are also depending on other systems. And specialists can be more effective by concentrating their expertise on the design of the reusable components. So these are some of the advantages. In terms of there are many types of approaches that we have come across with. One of it is application framework. This is more at the programming level where you have running program with a collection of concrete and abstract objects that are designed to reuse through specialization and by adding new objects. So these are application framework, and then you can come across with a software product lines where it is basically related to application that have been developed for more and one or more base application. Okay. A generic system is adapted and specialized to meet specific requirement for functionality, target platform and operational configuration. And then we have application system, which is another approach to system reuse. It is concerned with reuse of large scale off the shelf, meaning that this is a ready system which you can reuse. It provides a lot of functionality, and their use can be radically reduce cost and development time. And then you have also, we come across with potential problems with application system reuse. Among it is that you are not able to control the functionality and the performance. In case for system evolution, you don't have control over it, and then maybe you don't have support from the vendor.